Concept video. Topic binary adder. Name Shyam Kumar. Rule number 21951A12C9. Section ITB. Subject Computer Organization Architecture. COA. 4-bit binary adder. A binary adder is a digital circuit that performs the arithmetic sum of two binary numbers provided with any length. A binary adder is constructed using full adder circuits connected in series, with the output carry from one full adder connected to the input carry of the next full adder. Binary. What is binary adder? Binary adder is a digital circuit that implements the arithmetic sum of two binary numbers supported with any length is known as binary adder. It is generated using full adder circuits connected in sequence. The output carries from one full adder linked to the input carry of the next full adder. The aggregate bits of A and the ANDed bits of B is created by subscript numbers from right to left, with subscript 0 indicating the low order bit. The carriers are linked in any chain by the full adders. The input carry to the binary adder is C0 and the output carry is C4. The S outputs of the full adders rate the needed sum bits. An n-bit binary adder is needed and full adders. Thus, output carries from each full adder is linked to the input carry of the next high order full adder. The n data bits for the A input come from one register including R1, and the n data bits for the B inputs come from another register including R2. The sum can be transferred to a third register or one of the source registers, R1 or R2, restoring its earlier content. Full binary adders are arithmetic circuits in the form of adders. Of adders be used to add together two binary digits. Another common and very useful combinational logic circuit which can be constructed using just a few basic logic gates, allowing it to add together two or more binary numbers, is the binary adder. A basic binary adder circuit can be made from standard and XOR gates, allowed us to add together two single bit binary numbers A and B. The addition of these two digits produce an output called the sum of the addition and a second output called the carry or carry out, COUT bit. According to the rules for binary addition, one of the main uses for the binary adder is in arithmetic and counting circuits. Consider the simple addition of the two denary base 10 number below. From our maths lessons at school, we learnt that each number column is added together starting from the right hand side, and that each digit has a weighted value depending upon its position within the column. When each column is added together, a carry is generated if the result is greater or equal to 10. The base 10. the base number. This carry is then added to the result, the addition of the next column to the left, and so on. Simple school math addition: add the numbers and carry. The adding of binary numbers is exactly the same idea as that adding together decimal numbers, but it each carries is only generated when the result in any column 2 is generated or equal to the base number of binary in other 1 plus 1 creates a carry. Binary addition. Binary addition follows this same basic rule as for the binary addition above, except in binary there are only two digits with the largest digit being 1. So when adding binary numbers, a carry out is generated when the sum of equals or is greater than 2 1 plus 1, and this becomes a carry. Bits for bit for any subsequent addition being passed over to the next column for addition, and so on. Consider the single bit addition below. Numeric codes. Numeric codes can define numbers. There are the following numeric codes, which are followed as weighted binary codes, non-weighted binary codes, reflective code, sequential code, cyclic code, error code, correcting code. Weighted binary code. Weighted binary code are those codes that follow the positional weighting standard. In this code, each position of the number defines a particular weight. For example, in decimal code, if the number is 345, then the weight is 3 is 100, 4 is 10, and 5 is 1. In the 8421 weighted binary code, each digit has weight of 8, 4, 8, 4, 2, or 1, equivalent to each position. Non-weighted binary codes. These codes do not follow the positional weighting standards in non-weighted codes. Each digit position within the number does not have any permanent value. Reflective code. A code is reflective when the code for 9 is a complement for the code 08 for 1, 7 for 2, 6 for 3 and 5 or 4. Sequential code. Sequential code are codes in which the succeeding code is one binary number higher than its previous code. An example of sequence. Cyclic code. In cyclic code, only one bit in the code modifies at a time while changing from one number to the next. It is a non-weighted code which defines that the position of the bit does not include any weight. Error correcting code. This code not only identify errors in data but also accurately them. Necessarily, this are those approaches by which a collection of symbols can be defined such that one bit of the description has thrown, we can definitely recognize the previous symbol. Alphanumeric codes. These are codes that include both numbers and alphabets. The mostly frequently used alphanumeric codes are ASCII and EBCDIC. Full adder. What does full adder mean? A full adder is a digital circuit that performs addition. Full adders are implemented with logic gates in a hardware. A full adder adds three 1-bit binary numbers to operands and a carry bit. The adders output two numbers, a sum and a carry bit, the term. is contrasted with a half adder which adds two binary digits. Techfopedia explains full adder. A full adder takes two binary numbers plus a carry. XOR and AND are gates and hardware. Thank you.